Hey guys, this is going to be the second video for Math 7, Lesson 97. Thank you for tuning in into the last video. Not like you had a choice anyway. And I have a whole 9 subscribers when I had 0 before. So, you know, this channel is going places. Anyway, hopefully by now I got a little bit more of experience in this, because yesterday your video didn't take me that long, but the 8th grade and then the algebra one and then the other ones took me a long time. So hopefully by now I got a lot more experience, and I'm going to try to be shooting these videos more regularly. So if I'm not answering emails or if I'm not answering in the Google Classroom, please try to Google Classroom. It's great. As soon as you write a comment, I get notified and I can go and just do that. So if you are not in the Google Classroom, make sure you are there. And I'm kind of confused because if you're not there, how did you get here? But you know, people do that sometimes, like Mason getting into the 8th grade class when he was supposed to only be in the 7th class, and I had to kick him out. And then Andrew getting into the 7th grade class, and I had to kick him out and invite him into the 8th grade class because apparently people don't know how to follow instructions. But, you know, hopefully they follow instructions now, you know, maybe. It's a learning process for all of us. So to say that is great. So hopefully we can get into this lesson, and I also get better at doing these videos. And so today we're going to do similar triangles and indirect measures. So let's take it. All right. So hopefully over here you can see my beautifully drawn triangles. I know. I'll teach you how to draw triangles later, maybe when we get back to school. You know, I'm such an artist. I know. And so here what we're going to do is we're going to look at the triangles and say, wow, they're similar. And if you don't see them similar, then use your imagination, okay? The Lord gave you one for a reason. So, yeah, let's do that. And what we're going to say is that angle A and angle Z are congruent, actually. They're not similar, they're congruent. And angle B and angle Y are congruent. And then angle C and angle X are congruent. Okay, so those are angles that are congruent. So what is congruent? In these two triangles, the ones that are congruent are the angles, okay? Congruent, remember, for geometry, it means the same measurement. Why isn't it called the same? Because in geometry, space matters. And so this angle is not the same as this one, because if they were the same, then there would be just one angle, okay? So it's two that look alike, that are the same, and that measure the same, but they're not the same because they occupy different space. So this is going to be angle A, which is congruent. This is the congruency symbol, the equals with the little squiggly line on top. Angle A is congruent to angle Z. And then angle B is congruent to angle Y. And then angle C, senor, is congruent to angle X. And then that's what we have congruent. Okay, so that is what's congruent, but then what is similar? Because that's the whole point. The lesson is similar, not congruent. And so the similar ones are, the ones that are similar are the sides. Those sides are similar. Side AC, remember to put the little line segment on top. It's going to be similar. This is the similar sign, okay? Not the congruent, but similar. It's similar to ZX, okay? And then side AB, with the little roof over their heads, is going to be similar to, right? To side ZX, ZY. ZX was already here. And then finally, YX is similar to BC. So we're going to put BC British Columbia. Not just joke. YX. And those are what are similar and those what are congruent, because the measurement of the sides is not the same. And so that's what it's the difference between congruent and similar for this triangle. So one of the things that you have to know is the corresponding similarity in the sides. So corresponding would be AC and ZX, or ZY and AB, or BC and YX. And that's what's important. All right. So now that we know those are congruent and similar, now we have to ask about corresponding angles and corresponding sides in similarity, because similar triangles will have corresponding sides. So it's really easy, because corresponding angles, are going to be angle A and angle Z, angle B and angle Y, angle C and angle X. Those are corresponding angles here, and then the corresponding sides are going to be side AC and side ZX, side AB and side ZY, and side BC finally, and side YX, not YZ. Good thing I have an eraser handy over here. YX. And these are the same as this one's over here, and that's how you find the relationship between corresponding angles and corresponding sides in similar triangles. And this is important because you need to be able to identify it when we see similar shapes. So in example 1, we have two similar triangles, and they say estimate the length of A and then find the length of A. I'm going to be honest with you. I don't really care if you can estimate, because what's the point of estimating when you can actually find the actual answer? So let's find the actual answer. And again, we're going to use something that I've been telling you have to know by now, and it's proportions. How are we going to show proportions? So this side 6, it's corresponding to this side 10, and so I'm going to put 6 over 10 as a ratio, and then I'm going to make it equal to 3 over A. Now, why does this make sense? It makes sense because 6 and 3 are in the same triangle. 6 and 3 are in the same triangle, and 10 and A are in the same triangle. Now, 6 and 10 are corresponding sides in similar triangles, and 3 and A are corresponding sides in similar triangles. Now we're going to do the good old cross multiplication. So we're going to multiply across. That's what cross multiplication means. And so what we're going to do is we're going to have 30, or 3 times 10 actually equals A times 6. Let's then divide 6 first. And there's two ways of doing it. Actually multiplying 3 times 10, which is 30, divided by 6, and A would be 5. Or crossing out 6 and 10, because I divided by 2. And so this is 5, and this is 3, and 3 with 3 would cancel out, and it's still 5. So it doesn't matter how you do it, you still have to get 5. A equals 5. And example done. All right, in the second example, you have to have read it. Please read the example. I know it's a word problem, but it says there is a pole that casts a shadow 24 feet, right? And then they put a 100-meter stick, and that meter stick in the same time of day casts a shadow that's 40 centimeters long. And so what you need to do is do a good old table in which you're going to put case 1 and case 2. So the first one is going to be the height of whatever you're looking for, and the second one is going to be the shadow. And so if you do the little table right here, this table is to help you out to see what you're doing. So the height of the pole, we don't know. So I'm going to put X. I know I put question mark here, but it's just X. The shadow, though, is 24 feet. I don't have to worry about units. And the reason is because if this is in feet and this is in feet and this on top and this is on the bottom, feet divided by feet is going to be 1. And so the units cancel out. And the meter stick is going to be 100 centimeters over 40 centimeters because that's what they tell us. This is going to be really helpful because then if you look at this little table, it already tells you what the proportion is going to be like. It's going to be X over 24 equals 100 over 40. Look at that. It's right there for you guys. And so then you're going to cross multiply. It's going to be 40 times X over 100 times 24. And I don't like to multiply right away. I would rather just divide first because the 40 and the 40 cancel out. So it's just going to be X. And then the 0 and the 0 cancel out because if I divide by 10, 100 divided by 10 is 10, and 40 divided by 10 is 4. And then if I divide by 4, and 24 by 4, divided by 4 is 6, and 4 divided by 4 is 1. And so I'm going to get 10 times 6, so it's 60 feet. The pole is 60 feet tall. All right, for the last example, they tell us that Brad is about 5 feet tall. He walked about a yard with each one of his steps. So he knew that his shadow was about 3 feet tall because 3 feet is a yard. And then he says that he walked close to the flagpole and then he tried to measure his shadow. And it says it's about 8 of his big footsteps. And so they give us a choice of all these 15 feet, 24 feet, 40 feet, and 60 feet for the height of the flagpole, but we don't know how much it is. How are we going to do that? Again, we're going to do 5 divided by 3 equals X over 8. And we're going to do the good old cross multiplication. 5 times 8 is going to be 40 equals 3 times X. And then we divide 3 on both sides. And this is going to be, well, we cancel this out. And 3 actually falls, it's going to be 13 1/3 feet for X. The reason being that if you actually divide 40 divided by 3, it fits 1 time. And so 1, and then 10 if it's 3 times 9, and then you have to, well, let's just leave the remainder, quote unquote, but it's not really a remainder, 13 1/3. So it's 13 1/3 feet, and because we know that 24 would be too much, 40 is way too much, and 60 is just ridiculous. The flagpole is it's about 15 feet tall. Again, that's one of the reasons I put this little sign here. I know that that's for similarity, but that's when we talk about geometry. When we talk about algebra or actual numbers, this little sign right here means approximately it's about 8 feet tall. So I know that the shadow of the flagpole is not exactly 8 feet tall. That's why I don't think that the flagpole is also not 13 1/3 feet tall, but it's about 15 feet tall. So it could be between 13 1/3 or 15 feet tall. And that is it. So that is lesson 97 for today. And hope you guys like this. If you like this, please like, comment, subscribe. If you didn't like it, well, too bad for you, I guess. I don't know what to tell you. But I want to thank all my likers, commenters, and subscribers because I already have 9 subscribers. So I went from 0 to 9. This channel is growing. This is crazy. Thank you for your massive support. It's been great. Maybe I'll get sponsored someday. You know, who knows? But I'll see you then in the next one.